Hello everyone, thank you for coming to my channel. Today I will be showing you how to generate DEM, which is Digital Elevation Model, using Snap based on satellite images from Sentinel-1. First of all, we need to obtain our satellite images first, which you can download it from the Copernicus website, and it is free, where you can register and create your own account. And as for me, I already created my own account and I can proceed for logging in. Okay, first of all, we need to tick first the Sentinel-1 satellite, and we tick the level 1 SLC and level 1 GRD, and we can also filter where the operational mode we use the IW, and for the polarization we use the VV plus VH. Then for the year, you can set your own time range. As for me, I already set it, which is from the 1st January 2018 to the 31st December 2018. And after you set already the time, after already set your time range and your filter, you need to draw your polygon uh, at your area of interest or your study area. As for me, I will draw around my university, and this is to ease us for or save us a time for search later for our satellite images around our study area. And then after that, you can click your search. As you can see, the Copernicus list down all the satellite images that is around your study area, that you have drawn the polygon. And uh, there are many types, or there are many of the satellite images from the Sentinel-1 that you can choose, ranging from 1.6 gig to 7 gig. uh, so you can download whichever you want. But you need to make sure your orbit direction and operational mode and polarization channel, as well as your relative orbit number, and uh, relative orbit number must be same with your other images that you will downloading. uh, so I will search uh, another satellite image. Okay. I will download this one. Since the process of the downloading is taking a long time, so I will be skipping it for this video. Okay, we already done with downloading the data for the 2018. Actually, we need to download another one for the 2018 data. uh, so there will be so there is a process in the snap that requires at least two images in for each year to process it. but I already have downloaded the another 2018 satellite images, so I will proceed in downloading for 2023 Sentinel-1 images. Same setting like 2018 satellite images Sentinel-1. The one that changes is only the year, which is set it to 2023, and then we can search it. Same ranges of size storage from 1.6 gig to 7 gig. So we need to search the 2023 satellite image that has same condition with the 2018 one, such as their orbit direction, their product type, the SWOT identifier, and the slice relative orbit number. All of them must be same with the 2018, and also the polarization channel. As you can see, all of this condition has the same one with the 2018 data, so we can proceed with downloading it. Uh, wait, I need to cancel it first. Sorry. Okay, we can download this one. As you can see, the process takes a long time since it is big storage, which is still 7 gig. So I will be skipping the video and come back to you when the downloading is done. Okay, we are done with downloading the satellite images from the Copicus website. Now, before we proceed with processing the Sentinel-1 images, we need to set up a few tools for processing before proceed with processing. First, we need to check for any update for the plugins. As for me, I already installed all the available plugins. uh, if you haven't or not yet already update your plugins, you need to do so, because it is imperative, because for processing, especially the plugins called Snap-Who. As for me, as I said, I already update already all the plugins, so I will proceed with the manage external tools. For the external tools, you need also to reinstall it. So what you need to do is you click the Snap-Who and you click here and click bundle binaries, and for the target folder you need for the target folder you need to specify which folder you want to save your Snap-Who output. So as you can see, you can create new folder where it's is special for snap2 output only, and use this directory and copy it in this target folder, and download, and you can click download and install now. Click OK, and then OK. This mark symbol shows that the snap2 plugins is properly installed, so we can proceed with the next step, which is processing the Sentinel-1 satellite image. For first step, we need to specify our study area. First, we need to import our downloaded Sentinel images. So we go to where you arrange or you compile all your Sentinel-1 satellite image. Import all and click open. For the next step, you select the radar tabs, and you select the Sentinel-1 tops, and you select the split one. First, you can choose from IW1, LW2, or IW3. Depends on where your study area. As for me, my study area is at the columns of IW2, and you need to select the VV option because it has lots of energy, and you can determine which how many bursts you want to use, which may cover your study area. You just need to estimate it properly. Be careful, because when you do not when you mistakenly determine your proper burst, you may not cover your study area, so be careful with that. You can rename your file name, because the file name that the file name is already too long, so you can delete some of it. And this is for the 2023 image, and you can click run. You can repeat this step for other images. Same as before, make sure your burst cover your study area and your polarization is VV, and you click run. Okay, after you have done with the S1 top split, in specify your study area, you can delete the old one or you close product. And for the next step, we need to apply the orbit file for each satellite image, where you can click the radar tab and just click apply orbit file and specify which image first that you want to apply. Okay, for me, I apply for the 2018 first, and for the setting, you may use the default one, no need to change anything, and just click run. So this is for the 2018. Just use the default setting and let it run. After we done with applying orbit file for each image for every for 2 years, and then we will do the co-registration image, where we'll combine two image into one. For example, where we'll do the uh, co-registration for the 2018. First, we need to import the 2018 images, and then we will click the back geocoding. We will set the SRTM 1 second height for digital elevation model, and then we click run. You can see the combined images for 2018 has been renamed and as tag, and then uh, close this tab, and then we do the co-registration for the 2023 images. Click here and here, and then same as before, set the digital elevation model to SRTM 1 second height, and other settings we use the default setting and just click run. Okay, that is done, and we can close the previous step images, and then we move to another step, where we conduct the enhanced spectral diversity. Go to radar, and then go to Sentinel-1 tops, and I'm sorry, we go to here, co-registration, S1 top co-registration, and then S1 enhanced spectral diversity. here we just click the 2018 images. No need to change the setting, just use the default settings and then just click run. Alright, we're done with the 2018 image. So we proceed with the 2023 image. Just click run. No need to change the setting. Okay, we're done. And then we just close the previous step images. And then we proceed with the interferogram formation, where we go to interferometric, products, and interferogram formation. Select the 2018 image as the source product. No need to change the setting, just as before, just use default setting and just click run. Okay, do the same step for the 2023 image. Just click run. Okay, we're done with the interferogram formation. Just remove the two product, and then we will do the S1 tops deburst to remove the black line that may appear in the image. Here, as you can see, there's two black lines, so we need to remove that to enhance the image further. So first we go to radar tabs, go to SENTINEL-1 tops and S1 tops deburst. Here, same as before, just use the default setting, no need to change the setting, so just click run. Okay, do the same step for the 2023, just click run. Okay, we're done. Here, we just close here. As you can see, the black line has been removed for both images. You can see for the 2023. Okay, both images has the black line has been removed. So we're done with that, and then we can proceed with the next step with the Goldstein phase filtering. This is to smooth the image, to smooth further the image. So we go to radar, we go to interferometric, and then we select the filtering, and then Goldstein phase filtering. Same as before, just select the first image, the 2018, and then no need to change the setting, just use the default and just click run. Okay, do the same step for the 2023 image. Click run. Okay, we close, and then okay, for the next step we may proceed with the snap-to unwrapping, which is a bit complicated. First we go to interferometric unwrapping and snap-to export, and first we do the export for 2018 image, and in snap-to export we select the target folder. Up to you which folder or desired folder that you want to save it. As for me, I already created my snap-to folder and name it as unwrapping 2018 and select. For the statistical cost mode, we set as topo, and for the row overlap and column overlap we set as 200, and then other setting we use the default one, and you just click run. Okay, after that we do it with the 2023 image, and then just change the name of the output as unwrapping 2023 or up to you. And for the statistical cost mode we use the same one, topo, and other setting is just same as the 2018, and yeah, just click run. Okay, we're done with that. And for the next step of snap-to and unwrapping, we go to interferometry back, unwrapping, and click snap-to unwrapping. For the source product, we go to the previous step of the snap-to export, go to your save output for the unwrapping of the first image, which is for me the 2018 one, and select the first image where the format is the .img. Select the image and the processing parameter. For the output folder, you specify which desired folder for your first image. As for me, I will use the same folder of the previous one, which is the snap-to output, and select and just click run. The process may taking a long time, so I will skip the video until it's done. Here's the result after the unwrapping snap-to done with the 2018 image. The time length of the snap-to unwrapping is depend based on the burst that we set on the image. So that is for the 2018 image. Now we proceed with the 2023 snap-to unwrapping image. We go to unwrapping 2023 that we export from the previous step, and same as before, we select the first image for 2023 and click select, and the output product is just the same folder as the 2018, which is the snap-to output, and just click run. Same as before, the process is is taking a long time, so I will be skipping the processing until it's done. Okay, now we're done with the snap-to unwrapping for the 2023 image. Now we proceed with the third step, which is the snap-to import. So we go to radar, interferometry, unwrapping, and click here, snap-to import. For there are 4 parts. So for the first part, we need to input our first product. So we can use the product that has been opened from the previous step. First we do the 2018 image first, and then for the next part, second part, is the input or import for the unwrapped face that we have done from the snap-to unwrapping. So we just need to go to unwrapping 2018 and click the .hdr. The format must be .hdr to import it, and then for the third part we need to tick the box, and the fourth part is you output file. So for me, I will save it in the my default directory and just rename the file to unwrapping and just click run. Okay, we're done with the 2018 image. Now we do for the same thing to the 2023 image. Same step as before. Just go to input the HDR image unwrapped face for the 2023 and just tick here, already tick, and then we will rename it to unwrapping. So just click run and use the default setting, and we're done for the snap-to unwrap. Let me close for the 2 products, and then we go to phase 2 elevation DEM generation, digital elevation model generation. So we go to radar, interferometry, and click interferometric, and we click the phase 2 elevation. So first we do for the 2018 image first. Here we use the SRTM 1 second, and other than that just use the default setting and just click run. Okay, the 2018 image has been done, and then we proceed with the 2023. Just use the previous setting and just click run. Close the previous product, and you can see here is the elevation model that has been generated. See here. So for the next step, we want to do the display range Doppler terrain correction. So first step, we go to radar, geometry, terrain correction, and range Doppler terrain correction. We select the 2018 image as our first source product, and then under the processing parameter, digital elevation model, we set to SRTM 1 second height, and in the DEM, in the output bench 4, we tick the DEM, and then other than that, no need to change. This is the default setting, and just click run. Okay, the 2018 image done with the DEM generation. So we do for the 2023. Okay, the previous setting is still there, so we just need to run it. Okay, the terrain correction has been generated or been applied to the image for both image. Here is the elevation image, sorry, terrain correction that has been applied to the DEM. Here the wider here's the 2018 image, and here's the 2023 image. So we're done with the DEM generation, and terrain correction has been applied. Therefore, the next step is we need to export it to view it clearly on the Google Earth. So we right click the image and save the KMZ file in our desired folder. So I will put it in I will create new folder. Here open and just click and rename it to 2018 elevation. The process seems to take a long time, so I will skip the video until it save the image as KMZ for the 2018. Okay, the elevation VV for 2018 has been exported for its KMZ file. Now we do the same one for the 2023. Just export, go to your desired folder to save it here, and rename it as 2023 and save. Okay, the 2023 elevation VV KMZ file has been saved. Now we can close this. Now we do the same thing for 2018 and 2023 elevation model. uh, Same as before, just right click, view as KMZ file, go to your desired folder and just save it. And first you rename it to differentiate between the 2018 and 2023 elevation, and just save. Okay, the 2018 already exported its KMZ file. Now we do the same one for the 2023. Rename it and save. Okay, done with the 2023 elevation KMZ file exporting. Now we go to open the folder and double click the 2018 and also the 2023 elevation to view it in the Google Earth Pro. Just close. We untick the 2023 first. We want to view the 2018. As you can see, the image is properly positioned on the Google Earth Pro, and we can see the lowest elevation is 5 meter, and the highest one is 81 meters, which is quite logic, where the 5 meters embodies the body water, and the 81 meter mostly encompass or cover the hill or mountainous area of the image. Now we want to see our study area, which is UTM here. And for your information, UTM area is also covered with lots of hills and slope around it. So here's the 3D view. We can see here. Here there's the hill area for the slope or the slope area in the UTM. And let's see for the 2023 image. We close the 2018 first and view the 2023 image. Okay, just the same with the 2018 one. No significant deformation or changes in the study area. So from what we can conclude here, here's the generated digital elevation model from SENTINEL-1 from snaps using snap software, which reveals the overall elevation pattern within our study area, which is UTM, University Technology Malaysia, with elevation values ranging from 5 meters to 81 meters. However, sut- subtle subtle difference in elevation distribution are observed, particularly in certain highlands and lowland zone. These variations may indicate minor terrain changes such as ground settlement, vegetation growth, or construction activity, and so on. Although no major deformation processes ever over the 5-year period, it is still necessarily to accurate out to on detecting small scale elevation changes, such as using DEM of difference. And yeah, this is our final output for generating DEM using snap software. And thank you.